Hi everyone, my name is Scott Allen and I am the sales engineer for Losant's Solution Group. And today I'm here to show you an example of a smart environment application. Now to us, a smart environment is a floor, a building, or a group of buildings that you want to track their number of people in an area, building temperature, humidity, outside temperature, and other factors that affect how people work in that environment. We know of three main groups that are interested in tracking a smart environment. First is facilities, because they need to make sure that the environment is safe and comfortable. So they're tracking temperature, humidity, and other factors to make sure that everything is comfortable. To them, the faster that they are aware of a problem, usually it's easier for them to fix. Next is the security group, because they need to know where people are in case of emergency and they can respond accordingly. And finally, there is the facility management group, who want to know how the resources are currently being used and what resources will be needed in the future for the group. So let's go ahead and show you actual smart environment. Now, what I'm showing you is not a simulation. This is actually smart data that we are receiving for the 7th floor of the Losant headquarters in Cincinnati, Ohio. So all the information you're seeing here is real information we are collecting about our own environment. The dashboard that you're seeing here is made up of the usual dashboard blocks. You see there's standard indicators, but there are some that require a little extra explanation. So let me give you the overall layout first, and then we'll go into the details. First, we have a floor plan of our 7th building and where we have sensors or conference rooms in that particular floor. The indicators here show us if there are people in the conference room or not, or if it's a sensor, whether it's been sending good information or not. We also have blocks of data here that can tell us if a room is currently in use or not. Green means that the room is available. Red means that it is not. Somebody's using the room. On this particular floor, we have two conference rooms, the front and the back conference rooms, and then we have individual call booths made for one person to go in, connect, and make a phone call or talk to a customer without being disturbed. We also have some standard indicators here of the air quality on the 7th floor. We have a couple of different ways of looking at the data. First, we have these gauges that will tell us everything from carbon monoxide levels, which is hopefully at 0, to carbon dioxide, humidity, temperature that we see here, both at the last reported value and the values over the last 24 hours. Also, for each of our conference rooms and phone booths, we can look at the temperature and humidity within that area just to make sure that everything is going well. We have some other sensors as well, like a Sonos music player, a movement detector by our front elevator that can tell us when people are coming and going, and you can see that most of the people come on the weekdays, and on the weekend there's not much activity at all. We also have 3 fans throughout the floor. The X's indicate that the fans are off. The green with the cloud icon indicates that the fans are currently going. We have ways of controlling them from here. We also have a couple of different ways of seeing which conference rooms, which areas get used the most, and at what particular times are they used. And then we also have some information about the sensors themselves as we're receiving them. So pretty standard through most of the blocks, but a few of them do require some extra explanation, and that's what I'd like to show you now. The first one to show you is this floor plan of the 7th floor and where things are laid out. The way that we made this particular block is we use the position chart, which is one of the blocks available to you on your dashboard. Now the position chart has a number of things for you to define. First of all, you need to upload and specify the file that you want to use as your background image. In this case, it is this kind of hollow floor plan that we have here. Once you've defined the image you want, you defined the top left and bottom right hand corners and the coordinates you want to use for those positions, because all of the other information that we place on that floor are relative to these 2 points. Then for the items that we do want to track on the floor plan, we specify attributes of those items that we are going to use as coordinate system. So each of the points that you see here on the floor plan have a device attribute called indoor X and indoor Y that we can use then to place and position properly on our floor plan. And then we also have the ability to change the color of those indicators. In this case, we're looking at if the room is empty, it's green. If the room is busy, it's red. If it's more of a sensor, if it's green, that means we're receiving good information. If it's red, that means we haven't received good information for a while, and we probably need to check it. So all of that is available on this type of dashboard block. Also, for each one of these, if I click on a particular icon, we can see what that particular sensor is, its location, just to give us a little bit more information. And the way that we do that is by defining the pop-up bubble display for this chart. And so we look at one of the attributes is the last point, and that way we can display the name for that item. The 5 hash marks means that we're displaying it in a boldface font. We're showing the current time and the coordinates for that particular item. So this can be applied to maps, floor plans, anything that you want to show a position of your sensors or your conference rooms. The position chart is the best way to do that. Now, one of the other items that probably needs some explanation are these charts that shows us how busy each conference room is, broken down by day of the week and by time of day. The bigger the circle means the busier that particular room is. In this case, we're tracking every time we detect motion in those rooms, and we have one of these for each of our conference rooms and call booths. That way we get a good idea about how they're being used. Now, these particular data blocks are the custom charts that we have here that are using the Vega Lite graphic system. And so what we do with these is first we define the system, the data that we want to process on this particular block. So we have, in this case, the front conference room, where we are detecting the motion attribute. We're looking at data for the last 30 days, broken down into 1-hour increments, and we're summing up the amount of motion that we detect for every hour. And so once we have that information, we use the Vega Lite spec block to define everything from the x-axis, y-axis, title for the charts, and also the type of information that we're going to display based upon the size. So we can define the color and the size of each circle based upon the number that we receive. You can also display this information in a number of different ways, but it's a really good way to see how things are being used. Here in the preview section, we can see that our main conference room gets a lot of activity on Mondays, which is when most of our departments have meetings, and the time of day that most of these meetings occur, which are generally between 10 a.m. and 3 to 4 p.m. We do have some activity after that time, which is what the purple dots indicate, but it's relatively small compared to those more active times. The other blocks that are part of the dashboard are very standard, where you pick the device and the attribute that you want to display, and in a way that works best for you. Now, I did want to show you some of the information, the way that we've designed this application behind the dashboard. So the first thing I wanted to show you was how we've defined one of these devices. One of the items that we have on our floor is a quiet light. And the quiet light is a light that we've mounted to the wall that glows red when we want people to keep their noise to a minimum. We're usually recording something at that time. Or it will glow green when it's okay and you can make the normal amount of noise on the floor. The quick quiet time light allows us to change that just by clicking a button on our dashboard. Now, the device itself is more of an industrial light, and so it uses Modbus as a way to communicate its current status and for us to define a setting for how we want that to be. So in our environment, since it is a Modbus device, we've connected that to an edge compute device so that we can get the information to and from the light. So in our environment, we have a edge compute gateway, and what it is doing is getting the status from the light so that we can see that on our dashboard, but it also allows us to change that status. So the light itself has very simple attributes, a status of whether it's on red or green, and then the coordinates of where it is. That way we can track it on our floor plan. It also has just some very simple device tags that we've put on it. The type of device it is, it's a sensor, its position where we normally keep it, and its location, that it's on the Losant headquarters on the 7th floor. We have a completely set of devices on other floors, so it's important that we keep them separate. That way, when we're displaying the dashboard, we're displaying the dashboard for the right floor. So, pretty simple setup for the device. Now, when the time comes for us to actually control the light, what we're going to do is on our dashboard, we're going to come down here to the quiet light controls. Right now it's currently green, which means people can make whatever noise they want to make. However, if we want to change that so that we can do our recording, we can hit the button that says Enable Quiet Time, which will turn the light red. When we're done, we can say Disable the quiet time, which will turn it back to green. So the way that that works within our environment is through a couple of workflows that we have in our system. The first workflow is one that will take the user selecting one of those two virtual buttons on the dashboard and then acting appropriately. So here, if I hit that green button that said Enable Quiet Time, we're going to go through this path here on the left. When I disable it, we'll go through the path on the right. Both are the same, except for, in this case, what we're going to do is send a command to the edge agent, the edge compute device, that will allow us to change the color of the light. So we're going to send this command, quiet time off, to the edge compute device and have it control the light. Now, the edge compute device will also follow a workflow, very much like what we did for the platform workflow. In this case, what will happen is that when we send a command to the device, the first thing we're going to do is perform a switch event so that we know, are we turning the lamp on or are we turning it off? In other words, are we turning it green or are we turning it red? So in this case, when we're turning the light off, let me switch here, what we're going to do is go through this path in the middle. And so what it will do is write to the Modbus address with the port and also the registry settings to make the light turn red. In this case, it's 5 and 4. That will be very different if you're using different Modbus devices or if you're using another protocol like serial devices or something. So this is very device specific as far as the commands that we're sending it. So we're sending it the Modbus condition, and that should take effect immediately. So then what we're going to do is look at the address of those two registry settings, and if need be, we're going to change the device state so that our dashboard is accurate and showing the same status as the light itself. So then what happens is, if I go back to our previous workflow, here we can see, oh, we've changed the status for the device, and we're going to change the lamp accordingly, so that if I were to click that button here, we would see this turn red, and then at the end it will turn back to green. So this was just an example of how we would be using our workflows, not only to gather the information from all of our sensors, but also to control it when necessary or when we need to, right here from the Losant platform. So I hope this was an informative explanation of how we created our smart environment application. Please contact us if you have any questions about how we did things, or if you have questions about your environment and how you would map it and control it. Otherwise, thank you very much for your time. Have a good day.